Hello everyone. In the previous video, I introduced a linked list and showed its utility on how we can have a dynamically changing or dynamically sized data structure that can kind of act like a container, right? It's analogous to an array, how an array can act like a container of a single data type. So do linked lists. The benefit of linked lists is that we can add dynamically to anywhere of the linked list a new piece of the structure or a node. So where I was leaving off with this in the previous video is that it's kind of a pain for me to write this while loop twice. And if I keep adding nodes, I'm probably going to add it a few more times. So why don't I do something where I take this and I transform it into a function. So let's say I go here and I say void, and I'll create a function called print list. So what should be its input? Well, it should be a link list. Let's just call it head. No, let's call it node for an arbitrary node. And then I'll put this here. I'll end this. But what's the data type of temp that I need to grab? It's this. So we'll put this here. Right, so how this function will work is that we'll have a linked list node, and we'll create a pointer to a linked list called temp. Temp will point to the node that we want to start printing at, and it will print until the end of the list. So if this is the case, what data type should we be putting there for a linked list? Well, we can do something where we have this linked list node, and we can get the address of node here. But however, when I do this, what I'm actually doing is that I'm passing a copy of linked list node. And that can get confusing, because then I'm going to be generating two heads to this linked list. And that doesn't seem right to me. I think it would be better if I made this a pointer. So I'm going to keep a pointer. And then I can get rid of the address. So what I do now is that I take node, I copy it over to temp, and while temp is equal to null, I go and print this value. I have a temporary pointer to that. So what does this mean in terms of functions? Well, now we're not taking a copy of the linked list value. We're actually taking the variable itself. This is called pass by reference. It's pass by reference when I'm taking the variable itself as the input, not a copy of it. If I got rid of the asterisk here, this is pass by value, which means I'm going to be taking a copy of the input here and working inside of the function with a copy of my input. But because I'm using a pointer, this is pass by reference, and I actually get the variable itself that I'm using. And let's see an example of this function in action. We can get rid of this. I can say here print list. I can pass it the address of head. Here I can get rid of this. And here I can pass it the address of L1. So let's see what happens. Oops, I have mistyped my own data type. Things should be fixed now. So nothing's changed. However, what I did now is that I made a function for print list instead of having to copy this and redo this over and over and over again. And actually, while I'm at it, I'm going to try putting const here. Let's see if const works. Ideally, it should. Yeah, I want a copy of that. Or, we can get rid of it for now. But it's pretty neat that const works, just so that we don't change the data of the original node. However, the compiler gives a warning. So for now, this is where we're going to stop with using linked lists and pointer for our example for pointers to functions. I want to start highlighting the pass by reference and pass by value. So let's move out here. Let's go back to pointers. So I'm going to make a new file called PTR with functions. So here we are, and let's set up a variable. I'm going to say int z equals 12. And up here I'm going to create a function, and I'm going to say void. I'm going to call it add 5. It's going to take an integer int as its input, and it's going to say I plus equals 5. And that's it. So what happens if I call add 5 here? And I decide to print z. Well, 12 remains the same. But what happens here if I say, if I have another function called add 5, not fave, pointer. So instead of taking just an integer x, it takes a pointer to an integer. And since I want to access the numerical value, I need to dereference it. And I say plus equals 5. Okay, let's take a copy of these two. We can print them here. Get rid of this. You can do add 5 pointer now, and let's see what happens. Oops, I needed to give it an address. Right, since it's a pointer, I need to provide it an address, and I'm going to do so here. Let's compile. We'll run a.out. Oh. Right, remember that indirect changing? Well, it still applies to functions. So I have a pointer here, and if I dereference and use it, since I'm passing it an address here, I'm modifying it. So here I'm actually modifying z, where normally this wouldn't be a problem. And this highlights the big difference, because this is going to be pass by, what's the one word actually? Pass by value. We'll make it 2. Pass by value. And here we have pass by reference. So to beat this into your head one more time, pass by value is when you have a function and its input, it takes a copy of the function that calls it. So in main, the function is called. So we actually take, when we call add 5 on line 15, when the code from lines 4 through 6 run, it takes a copy of z and does whatever manipulations that it does. In this case, we're adding 5 to that value. However, if we're passing by reference, we're passing the variable itself. So on line 18, when I do add 5 pointer, because I'm passing the address, whatever I do to I, it's going to affect z. Here I'm permanently changing z. And here's that indirect modification that I was talking about earlier in the last 3 videos, where you can indirectly change the value of a variable through a pointer. And I mean, this is one way of doing it. So this is pretty interesting as well. The last thing that I want to highlight is that this is one way here of calling this function. Something else that I can do, I can say int q equals the address of z So not only can I do add pointer this way, I can actually do this. And what we're going to see is 22 when we run this code. Right, and there's two different forms of essentially passing pointers to a function that takes a pointer as an input. Either you can create the pointer explicitly like I do here on line 15, and I can just pass that variable itself because q is a pointer to an integer. And on line 9, add 5 pointer specifically asks for an input that's a pointer to an integer. So because q and I on line 9 are the same data type, I can just pass it as is. However, on line 20, z is just an integer. It is not a pointer to an integer. So pointers to integers require addresses. So I use the address operator on the integer to give it a value that's compatible with a pointer to an integer. And this all makes sense because a pointer to an integer requires the address of an integer. And I can provide it the address by using the address operator. Again, that's the ampersand sign right here. That's the ampersand sign here. And I can pass it an address. And because I do, I'm able to pass this as if it was a pointer. In the next video, I'm going to talk about the relationship between pointers and arrays. See you in the next one. Bye-bye.